Hey guys, Ms. Gosling here. In this video, we're going to be discussing the scale of the universe. By the end of this video, you will be able to describe the units that we use to measure the universe. And you'll also be able to convert between these units and standard units. So let's go ahead and get started. So before I get too into things, I do want to just review with you the understandings, applications, and skills that IB expects from you. So IB expects you guys to understand the different astronomical distances, and they expect you to be able to use the astronomical unit, the light year, and the parsec, which are the 3 units of distance that we're going to be learning about in this video. So the first thing I want to do is just talk about how big the universe is, because I think it's one of those things that's so big we can't really comprehend it. So our universe is 4.35 times 10 to the 23rd kilometers. So that's 435 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 zeros. That's huge. If I was standing on one side of the universe, say over here, and I shone a light, it would actually take that light 94 billion years, so that's 94,000 million billion years to get to be seen on the other side of the universe. So if I shone a light right now, 94 billion years from now, somebody across the universe would see it. What's pretty cool about that is that means that when we're looking at things that are far enough away in the universe, we're also looking at them how they looked backwards in time. So if I'm looking at something that's 94 billion light years away, I'm looking at it how it appeared. I'm seeing it how it appeared 94 billion years ago, because that's how long it took that light to reach my eyes. And there's something deeply beautiful and mildly frightening about that, I think. So, moving away from some of the discussion of the beauty and the size of the universe, some of the mysteries of the universe, let's get down to the nuts and bolts. So when we talk about the distance of the universe, we need to introduce 3 new units. So the first is the astronomical unit, which we use AU as our unit. So if I'm measuring something in astronomical units, I would say it is, for example, 7 AU away. And the astronomical unit is the distance from the Earth to the Sun. So that's about 1.496 times 10 to the 11th meters. Light years, which I use LY as my unit for, is the distance light travels in a year. And that's 9.461 times 10 to the 15th meters. That is, and we are, just so you know, going from smallest to biggest measurement of distance. So astronomical units are the smallest. Parsecs, the last, are the largest. So this is the largest distance we can use to measure space. I will get into, in a later video, I will get into how exactly we get where the parsec comes from. I'm not going to worry about that right now. But it's equal to 3.26 light years. And 3.086 times 10 to the 16th meters. Now, a fair warning, these units are not in the data booklet. So my recommendation for you, make sure, so you may need to be able to convert from light years to meters. That is the only conversion factor that you should have to use if the number, where the conversion won't be given to you. Otherwise, the conversion factor should be given. So you should be given what the distance of an AU is and what the distance for a parsec is. But it is never a bad idea to memorize unit conversions. It always makes your life easier if you don't have to look it up. So let's go ahead and look at an example. Other than the Sun, our closest star is Proxima Centauri, which is 4.24 light years away from us. How far are we from Proxima Centauri in meters, in AUs, and in parsecs? Now, what I'd like you to do is take a moment, pause this video, and see if you can do the unit conversions yourself. If you're stuck, I want you to go back to the previous slide and take a look at what the conversion factors are, write them down, and then come back here, pause the video, and try doing the solution yourself. Okay. So hopefully you've taken a moment to pause and do the calculations. Let's go through them together. Let's see if you know what you're doing, if you did them right. So let's start with part A. So I know that 4.24 light years is what I am converting away from. And I want to go from light years to meters. So I'm going to put meters in the numerator and light years in the denominator. 1 light year is 9.461 times 10 to the 15th meters. And when I stick that in my calculator, I get that the Proxima Centauri is 4.01 times 10 to the 16th meters. And what I did was I multiplied 4.24 times 9.461 times 10 to the 15th, and then I divided by 1. So I multiplied across the top, and I divided across the bottom. So moving on, let's go ahead and take a look at B. So for B, I'm asked to find our distance from Proxima Centauri in AUs. So let's go ahead. My conversion factor converts from meters to AU. So I'm converting from meters to astronomical units. So let's go ahead and start with my answer to A, which gives me my distance in meters. 4.01 times 10 to the 16th meters. Then I want to convert from meters, so meters goes on the denominator, to astronomical units, so AU goes in the numerator. I know 1 AU is 1.496 times 10 to the 11th meters. So I'm going to again multiply across the top, divide across the bottom, and what I will get is 4.01 E16 divide times 1 divided by 1.496 E11, and I get that my distance is 268,000 AU. So that's my answer to B. Now I'm ready to do C and convert from light years to parsecs. So the conversion factor I gave you gives you the conversion to parsecs from both light years and meters. So you can decide what to do. I'm going to use light years because, quite frankly, 3.26 light years per parsec is a lot nicer than 3.086 times 10 to the 16th meters per parsec. So I'm going to avoid the scientific notation altogether. So I start with 4.24 light years, and then I'm going to convert from light years to parsecs. So since I'm getting rid of light years goes on the bottom, parsecs goes on the top. According to my conversion factor, 1 parsec equals 3.26 light years. So I'm going to put the number 1 next to parsecs and the number 3.26 next to light years. Again, I'll multiply across the top and divide across the bottom. So 4.24 times 1 divided by 3.26 gives me 1.30 parsecs. There you go. So now that we've done a more standard example, let's take a look at an IB example question. The astronomical unit, AU, and light year, LY, are convenient measures of distance in astrophysics. Define each unit. So our command term here is the word define. And what that means is IB wants you to tell them what is the definition of AU and what is the definition of light year. So what I'd like you to do is take a moment, go back to your notes, and write me a definition for each of these 2 units. Pause the video, and on your piece of paper, I want you to write down the answers that you have. I am going to go ahead and do the same. Okay, so hopefully you've paused and written down your answers. Here are mine. So I defined an AU as the distance from the Earth to the Sun, and a light year as the distance that light travels in 1 year. Let's go ahead and take a look at the IB mark scheme to see how well my answers fit. So as you can see, our mark scheme gives very specific language for both the AU and the light year. The first thing I want to point out here is in my mark scheme, I've got these little brackets next to the word average. That means this word is optional. It doesn't need to show up in my definition. The rest of this definition doesn't have brackets, which means all of it should appear verbatim. So this defines a parsec as the average optional, distance from the Earth to the Sun. So if all you wrote was distance from the Earth to the Sun, you would still get the point. Light year is defined as the distance light travels in 1 year. These match my two definitions. The one thing that's key, though, is I wrote a year instead of 1 year. And so to be more careful, I probably should have said 1 instead of a, because that makes it very clear that I'm talking about 1 year, not more than 1 year. And remember, this is physics, so clarity is everything. So that brings us to our takeaways. So first of all, astronomical units, light years and parsecs, are convenient measures of distance in astrophysics. They all measure distance, not time, even though light years and parsecs both maybe sound like they could be measurements of time. So it's important to know these all measure distance. We can also convert between these 3 units and our SI units, which of course for distance are meters. So you now know all about the scale of the universe, and you know a little bit about how we measure distances within our large, wonderful universe. So take a moment to process before you start solving. But best of luck and happy learning.